You need a platform to support up to 80 cores. 80 cores? In 2 sockets? Ah, Team Blue. I love SuperMicro. They're just... It's the generic SuperMicro server box. And then what's in the box? This is the MBD12 DPI NT6-0. Man, SuperMicro, we gotta work on better motherboard names. The X12 DPI comes with a quick reference guide. This is cool. This is a sheet. This is something you can put up in your cubicle and refer back to it. Although most people are not really DIYing your servers. A lot of the time people will buy DIY servers like this to run an experiment, to just do some tests before they order the same thing at retail from Dell or HP or SuperMicro, because SuperMicro makes chassis. SuperMicro, yeah, they make everything, not just boards. These are the boards that go in the chassis, in fact. So this is the closest thing that you could get. In the box, it's pretty minimalistic. You've got this SATA plus control. Let's get the control cable breakout. Then we've got our CPU retention brackets. This one has metal things that go in the corner. So this holds your CPU to the heatsink. We got 2 of those because it's a 2-socket system. We have our rear I/O shield and the motherboard itself, which is enormous. Look at all this PCI Express routing and the traces, curved traces on the motherboard. I mean, they've done their homework here, because this is, after all, PCI Express 4.0. Our rear VRM has a heatsink, our front one doesn't, because again, this expects server levels of airflow. If you're gonna put this in a case, in a desktop case, you're gonna really have to dot your I's and cross your T's, because it expects server levels of airflow. Notice anything interesting about this board? Well, there's a lot of interesting things, but immediately your eyes should notice one thing. It's 18 DIMM slots. 18. Aren't we on quad channel memory? Shouldn't that be 16 memory slots? Yes, the new Xeon platform is channel memory. There should be 16 memory slots. The 2 black slots are for NVDIMMs. So if you're gonna get Optane or non-volatile DIMM, those live on the memory bus, because there's no other bus in the system that's fast enough to keep up with those. They go in the black slots. It's a pretty cool feature if you ask me. That's part of the reason why I have this board. But that's a video for another day. Both 8 pins are required for a heavily loaded configuration. There's even another optional 8 pin. They didn't solder it on this board because the CPUs that we're using, even at the 40 core end, those are 270 watt TDP. So they'll use, you know, a fair bit of power, but not too bad. We have 4 USB 3 ports at the rear of the board. We got RS-232 serial and our VGA for onboard out-of-band management. And then we have our 2 10 gig NICs, an Intel X550, and 1 management NIC. The M.2 slot is NVMe only. I don't really see another. There might be an option for a SATA DOM here somewhere. I think that might be SATA 4 and SATA 5, the orange ports on the board. But the headers here, you know, you can support up to 12 SATA devices right off of these headers. And then you've got an additional 2 regular SATA ports here for your OS, your boot drive, whatever. And as with all things SuperMicro, or many things SuperMicro, designed in the USA. Now normally I would recommend to just go ahead and get the SuperMicro bare bones. Don't bother with the motherboard, just get the chassis, power supply, motherboard, especially if you're building a test system. That'll be even closer to what you're gonna get at retail. I'm doing some special sauce stuff, so I get the motherboard. Now, in order to take this thing for a spin, we're gonna need processors and memory and the entire rest of the system. All right, so the idea is that basically you leave the CPU in the tray. Like if you're doing this properly, you leave the CPU in the tray, you mash the plastic thing down onto the CPU. There's actually 2 different versions of the CPU, P4 and P5. Intel hasn't really clarified what those are for. But our SuperMicro motherboard came with P4. You just mash the plastic down on gently, and then mash the heatsink down onto that, and then as one assembly, you put it into the socket. I installed a lot of 3647 CPUs, and every now and then there was just enough give or variance in the plastic on 3647, the previous socket, that it made me a little unsettled when I was putting it in, or it was just very slightly misaligned. And so you want to just wiggle it just a little tiny bit when you put it in, just to help make sure it goes into that socket. I'm hoping that that design flaw in 3647 is solved. I didn't have any problems with these, but I was scared to death. So it's only my second or third installation. Once you get them installed, you can flip the little brackets to lock it in and then tighten it down with the appropriate torque wrench. You don't want to over torque it because you can still crush it. Although, like I say, I think Intel's trying to hedge their bets a little bit with the plastic nuts that should just explode when you far exceed the torque, which is maybe a better situation than having your CPU socket get crushed. Also, a really important note, 120 millimeter, 140 millimeter. This motherboard would not support dual 140 millimeter coolers, but 120 plus 140 does actually work fine. Let's put this in a case. Now, if you follow in my footsteps and use this exact case, there's two things that you gotta know, specifically motherboard standoffs. You gotta pay attention to them. This motherboard's got 9 holes, but only 7 of the holes in the motherboard line up with places that are available to mount on the motherboard. No problem, you can use just a plastic standoff or a reversed motherboard standoff with a nut on top of it. So the one in this corner is not the same and not in the same place as it normally is. And the one in the middle bottom is not in the same place that it normally is. There is a standoff for the other peg that's in the middle of the motherboard, which is not in a normal place. But the one at the bottom doesn't have a threaded mount, at least on this particular pressing of this case. But the motherboard does fit pretty well, and there's a fair bit of room in here, so I like that. I definitely appreciate that. And this case has had some reach. It was very, very well designed. I think Corsair even has a carbon fiber one-off they made of this. Something crazy like that. It's really awesome that I've gotten as much use out of this case as I have. I got to juice up the fans here, make this a little bit more akin to server airflow, but that's fine. Just remember those standoffs, because if you don't, it'll short out and destroy everything. Well, I got my system put together. That's it behind me. Corsair 780T, full enchilada, the full build, 512 gigabytes of memory. Yes, I've got the Optane P5800X, as well as some older generation Optane, and it's already benchmarking. I'm wondering, this is level 1, you're gonna have to stay tuned for the actual benchmarks and benchmark results, or come join the forums. Usually I post questions or a little bit of a preview there, stuff like that. So I'm Wendell, I'm signing out, and I'll see you in the level 1 forums. And this has been a first build with the 80 core monster machine. A lot of benchmarks inbound. All right, signing out, and I'll see you there.